Hi, this is a final chance to go through some awkward questions on the statistics paper. This is a compilation of little parts of questions which students often lose marks on. In this first one, this is a normal distribution. You should know that when asked for an exact value on a normal distribution, the answer is 0. And here they're asking for the probability it doesn't equal an exact value, so the answer to this calculation here would be 1. In this question over here, you're asked to work out a missing mean, or in this case standard deviation, and you're given information of this type. That means that the normal distribution greater than 1.80 is 98%. This kind of question is done by creating a similar Z diagram, working out this Z number on your graphical calculator, and connecting this number with this Z number using the standardizing formula, which then gives you the value of sigma. This question over here is to do with the end of a probability question, where all of this information is taken from a table. So you have to work out the probability of picking 3 men at random. 2 of them have dark hair and the other one has medium hair. The individual probabilities for these can be found in the table. So you'll be doing, for instance, this calculation. But this is only one of the combinations. In this example, there would be 2 others. So you would have to work out each of these and then add them together. In this question over here, to do with a product moment correlation coefficient, they give you formulas which convert x and y values into u and v values. Then they ask you to work out the product moment correlation coefficient for this table. And then you're meant to be able to work it out for x and y. The key here is that this value here is the same as that value there, because this sort of process called linear scaling has no effect on the PMCC. Hi, on this one over here you've got a situation where you've got a scatter diagram and you need to learn to do a number of things here. This is quite a difficult part, interpreting the gradient of your regression line, which they've asked you to work out earlier in the question. Again, this is a set response, so you need to look at the value of your gradient. It'll either be positive or negative, so that's increasing or decreasing. Then you mention the amount for B, the value of B, so it's an increase or decrease by so much amount per unit increase in X, which in this case is represented by the pressure measured in kilopascals. This kind of question is quite common as well, giving a statistical reason why you can't use your regression line to estimate the depth for a pressure of 400 kilopascals, and the reason for that is extrapolation. It's outside the range of the data. And the other reason in context is obtained if you use your regression line to actually work out the value when you input this as your X value. So in other words, when you input 525 into your regression line, you'll get a value which isn't sensible in the context of the question. I've highlighted this question, which no doubt you've seen from June 2013. It's the pig question. And I just wanted to point out that in that question, they did ask you to work out the regression line equation using this type of summarized data. Make sure you know where the formulas are for that in your formula booklet, which enable you to do that. Also over here in this question, the only point to make is whether to use a table or a tree diagram. In a lot of questions where, for instance, you're given a probability based on something already happening, and you can tell that by the phrase given that, you're going to use a tree diagram. Okay, over here you've got a normal distribution, and in this normal distribution, the first part of the question involved fairly standard calculations, and then the second part they start talking about a random sample, in this case containing 10 bags. And then in part 1 and 2, they've got the 2 different types of questions relating to this. In part 1, they're talking about the mean of that sample. So you're basing that probability on this kind of diagram, one where you're using the distribution of sample means, which will have the same mean as the parent population, but the standard deviation will be 0.35 divided by the square root of n, square root of 10. But in the second part, they're talking about all the bags in the sample having a calculation a weight greater than 25 kilograms. So in that one, you use the normal distribution in part A to work out the probability of an individual bag being greater than 25, and then you do that to the power 10. In this question, which is based on a table, it's worth highlighting how to do a conditional probability. So if you look at part V, the probability is going to be fine given that he did not go cycling. Here I've started using the formula. So given that formula is the probability that is fine given that he did not go cycling is the probability of it being fine and not going cycling divided by the probability of not going cycling. The bottom part of that calculation you can work out quite simply from this table. The probability of not going cycling, in other words doing any of the other activities. But the probability on the top you might have to interpret. So what does this mean? Well, this means that it's fine and he does not go cycling, which in the context of this question means it's fine and he goes gardening. That's the only other option apart from cycling. So the top part of this calculation you would have to work out the probability of it being a fine day and him going gardening. Okay, on this question over here, which you again may have done about a machine that makes loaves and it's normally distributed and you had to work out what you think is a value for the standard deviation. This was to do with this idea that in a norm, if data is normally distributed, then you would expect most of the data to lie within 2 standard deviations of the mean position, and 3 standard deviations should contain over 99% of the data. So if you interpret this as meaning the lows will vary by 10 grams either way, that 10 grams would represent approximately 2 standard deviations. So obviously the standard deviation would be equal to 5. In this question over here, it's another table question with lots of easy parts, but over here in part B, they've asked you to work out or to determine whether the number of toilets and the number is independent of the number of bedrooms. To work that out, you have to use the formula, which you have to learn for independence, which is this one. So you would need to look at the number of toilets and the number of bedrooms. Does it follow this formula or not? Usually in these questions, these individual calculations you've already worked out earlier in the question. A very similar question to this is when you're asked to work out 2 things being mutually exclusive. Okay, in this question there's nothing particularly difficult except for one thing. You're asked for a confidence interval, but in the question the mean and the standard deviation are given in different units. So when you come to do this question, you will have to convert the 75 millilitres into litres. In this question over here about a normal distribution, the first few parts are quite easy and the second and third part are quite difficult. So to do part B, the key was you wanted to work out the probability of your bill exceeding 65 litres. The key to this was working out how much fuel you would need to buy to end up with a bill which is greater than £65. And you can do that because they've given you the cost of petrol. So if you do 65 divided by 1.34, you'll get the amount of fuel which is equivalent to a £65 bill, and then you're working that out based on the normal distribution information over here. In the third part here, in part C, I'm afraid you'd have to just think about it on the day. They do highlight any key words, so the bold words are important, any customer, whereas over here, this distribution was based on private car customers. So obviously if you were looking at large commercial vehicles, they might buy a lot more fuel than a typical private car. Also, this was about petrol, whereas generally any customer might also buy diesel instead. So in this question over here, there's a number of key features. You're given summarised data about the salaries of 50 full-time university employees. In part A, you have to work out the mean and the standard deviation. The mean is sigma x over n, and there's a formula in your formula booklet you should be aware of how to work out the standard deviation from this type of information. Here though, you need to now work out why you think it's unlikely that this information is distributed normally. The key here is you need to think about the criteria for a normal distribution: symmetry, discrete and continuous data. Usually those are based on table information, so sometimes you're given a frequency table where you can clearly see the data is discrete, or where there is skewed towards the beginning or the end of the table rather than symmetrically about the middle. But the main criteria why something may not be distributed normally is to do with the relationship between the mean and the standard deviation. You should find you can go within 2 standard deviations of the mean position. And once you've calculated the mean and standard deviation for this question, you'll find this is a problem and leads to negative salaries, which doesn't make sense. However, in B part 1, the reason you're still able to construct a confidence interval, which is based on x bar, is because even though the population for university employee salary So on this question over here, you've got university employee salaries. For part A, it's important you know how to work out the mean and standard deviation when you're given summarized data like this. In this part over here, to understand why the salaries are unlikely to be normally distributed, you need to make use of this information, that in a normal distribution, you should be able to go within 2 standard deviations either side of the mean. Once you've calculated these 2 figures, you'll see that that's an issue with these numbers for this data set because it leads to negative salaries. However, you're still able to construct a confidence interval because the x-bar diagram will be normally distributed because of the central limit theorem, which states that even though the parent population is not normally distributed, as long as you're using a large sample, you can still create a confidence interval. In this question over here, which is the endpoint of a question on a probability table, again, you've got to show that 2 events are not mutually exclusive. There's the formula for mutually exclusive. This means the probability of J or W or both. And this bit means the probability of J and W. And you've probably already worked these out, or you can work these out easily from the information up to this point in the question. Obviously, with the way the question is phrased, you're not expecting this formula to work for these 2 events, and you are not expecting this formula to work for these 2 events. Okay, in this normal distribution question, what we need to do is look at the last part of it over here. So you're given this time 2 pieces of information about this distribution, and you don't know the mean or the standard deviation. So this is similar to where one of them is missing. So for instance, this one over here would lead to this kind of diagram. Again, what you would do is work out a Z number that creates a similar sort of 5% area on the left hand side, and then that Z number would connect with that 400 in the standardizing formula. If you then rearrange it, you get that. But similarly, if you look at this information, you can create this diagram. You can create an equivalent Z diagram based on this information. They can connect in the standardizing formula and they lead to those 2. This equation here. And both equations are then solved simultaneously to work out the mean and the standard deviation. The easiest way to solve them simultaneously, is to subtract them from each other. They both have a minus mean. So subtracting them from each other will work. You've also got a simultaneous equation solver on your graphical calculator. This is a question where you're going to be asked to work out things like the mean, the median, interquartile range. It could be in a table or a list of numbers like this where something is missing. However, they give you some information about A and B, so when you're using a calculator, just pick any number which is less than 10 or bigger than 40 for A and B. It won't make a difference because initially you're asked to work out the interquartile range and the median. Over here, These are set responses. The mode is often not appropriate when there is no clear single mode. And over here, you can't use standard deviation because you don't know the values of A and B. Okay, in this question, which is group data, but it's continuous group data, and there's a gap between the end of one group and the beginning of the other, you have to understand that things have been rounded to the nearest value of the group. So for instance, over here, everything between 0.98 and 1.0 would obviously go into that group. But the end of the previous group and the beginning of the next group are these two values. So basically, anything from the midpoint there to there would also go into this group 0.98 to 1.0. So this value here would be 0.975 and this would be 1.005. Later on, they get you to do a confidence interval, which is fine. You also have to state why the central limit theorem was not required. That's usually because you were probably told this is normally distributed data anyway. And for the final part, that which is also quite confusing, why is the confidence interval approximate? That's to do with the fact that you're basing it on data from this table. So you're using the data as a sample from which you've worked out an estimate of the mean over here and an estimate of the standard deviation, and that's why the confidence interval is also approximate. Over here at the end, you have to interpret this. This means the mean, the population mean, is greater than 1. Obviously, you're going to base that comment on what the confidence interval was. And here, this is the probability that x is in between those values is approximately 1. Again, if you look at the table, most of the data does actually fall between those two values, and therefore we would probably expect it to be approximately 1. This is a tricky question on drawing a regression line. They'll ask you to draw a regression line in this particular question, but you'll notice it doesn't start at 0, which means that what you want to do to draw your regression line is pick x values that you can actually plot on the graph easily, like these three, and you'll plot them to actually create your regression line. Remember, you must have 3 points plotted. Also, because it doesn't start at 0 here, be careful with where that regression line goes in terms of if they ask you to work out the y-intercept. It may be safer when you're working out the y-intercept to put x equals 0 into the regression line which you've calculated rather than using the graph. Okay, on this one over here, you've got a variety of issues to think about. The first part is a probability question, obviously. And the two techniques that often help with probability are to do with tables or a tree diagram. In the first part, a two-way table is probably going to be the best thing, because if you read the question carefully, it's all about Gary travelling to work using a car or a bus or a combination of the two. And you can fill this in quite easily because over here, this is 0.25. Then you're told the probability he uses his car with the bus or on its own is 0.6. If this is 0.25, think of a number with that 0.25 that combines to make 0.6. The other thing to notice is that he definitely uses one of those two options. So this square here will be 0 and all the options together have to total 1. In the second part of the question though, over here, as you can see, because they are giving conditions where probability is mentioned, if something's happened, this is going to be a tree diagram. So we're going to use the information in part 1, where Gary travels to work by car only, using a car and a bus, and then by bus only, and then Larry either travels with him or not doesn't. And that creates a tree diagram that will help you with this question. Okay, so on this question over here, only a couple of things to notice. State a necessary assumption in constructing a confidence interval. They don't mention it, but this sample, which is going to be the basis of your confidence interval, it has to be a random sample. They usually do say that, but that's the assumption. In this larger question over here, which you might want to try fully, In the earlier parts, it's a binomial where you work out various types of calculations here and here. And then you're going to use those calculations earlier to help you do the last part of the question. So I'll let you read the last part of the question first, and then you can pause it and then listen to the rest of this. So in the final part of this question, you're going to use information from earlier. If you've had a chance to read it now, here's the solution. In order for everyone who's booked tickets to get a seat, one of these two combinations would have to happen. Either in the minibus, at least one person would have to fail to turn up, and then on the bus, at least two people have to fail to turn up, and then you would multiply those two together, then everyone gets a seat on the minibus and the bus. Or if everybody turns up on the minibus, then at least three people have to fail to turn up on the bus. And that's another option that would work to ensure everyone gets a seat. And then you would work this out, and then add those two results together. This is a fairly typical kind of binomial question. You might just want to run through again that you're clear about all the issues in a binomial. Always start off with the n and the p clearly written. And typical of a binomial, they often change one or both of those values. So in the second part, the n value changes. Also, a lot of students still get confused about this sort of calculation with a binomial. Just have a look at a standard method. So we're looking at more than 10, fewer than 20. So first we have to be sure about the inequality symbols over here. Then if you look at a list, I usually draw a list and I tick the ones I do want. So more than 10 would be 11, 12, up to including 19. It wouldn't include 20, and it wouldn't include 10, 9, all the way down to 0. So if I do less than equal to 19, remembering that the calculator only copes with less than equal to values, that would work out all of this list, and then from it I can subtract less than equal to 10. Doing a list clearly and thinking about it is very useful because mistakes are very common in this type of question over here. In the final part of this question, fairly standard, you're going to be asked to work out the mean and the variance, or in this case standard deviation, using the formula in your formula booklet for a binomial. Then you're going to be asked to work out the mean and standard deviation of a data set using a graphical calculator, and then comment on these claims. And that's all to do with comparing the two sets of data and seeing whether the mean and the standard deviation are similar or significantly different. If either of them is significantly different, you're going to reject the binomial model, and you'll often have to then come up with an idea as to why the binomial model might not be correct, which is usually to do with one of the criteria of a binomial model. On this final question over here, I have simply highlighted the sort of set notation you need to be familiar with. It is a while since a question like this has come up, but it's still something you expected to know. So for instance, you should understand this here means D and R happening. So it's a probability of a detached house and no children living in it. This means D or T or both. So this means a detached house, or a house where there's two children living in it, or a detached house with two children living in it. This is the symbol for conditional probability, and this is the symbol obviously for something conditional probability, and this would mean D not happening. In this one here, because it's only one mark, you should be able to state it. So name the two events which are mutually exclusive. So this isn't a calculation. This is to do with looking at what D, R, S, T represent. And so for instance, you couldn't have a house with no children and a house with one child. They couldn't overlap, so that would be mutually exclusive, for instance. Again, looking at D and R, are they independent? Justify your answer, and it's using the word determine. Here you could use the formula. So you could work out the formula, the probability of D and R happening, which you've already got over here. The probability of D separately, and the probability of R, which you'd still need to work out. And if they multiply together to make this one, then they are independent. In this final part of the question, as you can see, you've got to define in context various statements, like for instance this one over here. So this is a union of not D and T. So not a detached house, and there's only two types in this question, a semi or a detached. So that means semi-detached houses or houses with two children in them, or both, which is semi-detached houses with two children in them. Similarly, to work this out, you want to work out the bracket first. So that's R union S, which means either houses with no children or one child, or both, which can't happen. So it's either, which is houses with no children or one child intersecting with detached houses. So in other words, all of that together would now mean you're looking at detached houses which have either no children or one child in them.